Hi guys, this is lesson 8.8. We're going to learn how to factor by grouping, which we will use this method anytime we have a cubic polynomial. And I'll talk to you about that a little bit in a moment, but first pause the video and write out these steps for factoring polynomials. We'll be following these steps as we go along. Alright, problem 1 gives us an example of a cubic polynomial. Cubic means that the highest degree of the variable is 3, which we can see we have 3n cubed. So this degree right here, is 3. So since that is 3, we have a cubic polynomial. Notice how there are 4 terms. So what I like to do when I solve these, I first make sure it is in standard form, which this one is, and then I just draw a little imaginary line right here to separate it into 2 problems. So let's just look at the left side and take out the greatest common factor, the GCF. So 3 and 12 can both be divided by 3. N cubed and n squared can both be divided by n squared. If I divide 3n cubed by n squared, I get n. And if I divide negative 12n squared by 3n squared, I get 4. Okay? And then I have a plus sign because this is a plus. And I'm going to now take the GCF of the right side, which is 2. They can both be divided by 2 and nothing more than 2. If I divide 2n by 2, I get n. If I divide negative 8 by 2, I get negative 4, like this. Now, once you have this, there's something you need to look for. You need to ask yourself, does this factor and this factor match? And if they do, what that means you can do is you can put these together in one factor, 3n squared plus 2, and then the matching ones go together nicely into one factor like this. And that's all there is to it. The reason we can do this is the distributive property, and we're just kind of working backwards. So if you look at this, as long as those other 2 factors match, we can get rid of this addition right here by putting them into these factors. Pause the video and work on Got It 1. Okay, you should have gotten the quantity of 2t squared plus 5 times the quantity of 4t plus 7. I will wait and look at your answer to Got It 1b in class. You might have noticed in problem 1 I did not mention checking for the greatest common factor of the whole thing first. I should have done that. That should always be our very first step. And in looking at this problem, you could probably recognize right away that the whole thing has a greatest common factor. So we do want to take that out first. And our greatest common factor of this whole polynomial is 4q. Everything in here can be divided by 4q. If we divide the first term by 4q, we get q to the third. If we divide the second term by 4q, we get negative 2q squared. And then the next one we get 3q. And lastly we get minus 8. And now don't stop here because we can now use grouping on that next thing. So I'm going to do 4q, and then I'm going to use the grouping method on the rest of this. So I'm going to draw my imaginary line. I'm going to take out the greatest common factor of the left side, which is q squared, divide, and then take out the greatest common factor. Oh, there is no greatest common factor. Yes, there is. I made a mistake. You probably already saw that mistake. This 8 should have been a 6. I was dividing by 4, not by 3. So our greatest common factor here is 3, and then we do q minus 2. Just like that. And then we look and we see, do these factors match? They do. So I'm going to keep this 4q out here. But now I'm going to put q squared plus 3, these two outside guys go in here, and then q minus 2. And then this is complete. Remember, I only need one of the q minus 2 because the distributive property, the way that it works, is really what's happening is this q squared is being distributed to this and this 3 is being distributed to this. So if we just stick them together in one thing, then they only have to be distributed to one of these. Alright, pause and go ahead and try the got it. Okay, you should have ended up with something that looked like this. It's okay if your 2h squared plus 3h comes before the h squared plus 6. In fact, it probably did, and that's totally fine. I was just trying to do this in my head. For problem 3, we're shown a picture of a toy, and it's made of several bars that fold together to form a rectangular prism, or you can unfold it to form a ladder. And we want to decide what expression can represent the dimensions of the toy when it's folded up. Alright, so volume is length times width times height. So if we have that the volume equals 6x cubed plus 19x squared plus 15x, we want to factor this. And since it's length times width times height, we should have 3 factors. So the first thing we look for is greatest common factor, which happens to be x. So then we go ahead and say we have 6x squared plus 19x plus 15. And now we can see we no longer have a cubic trinomial. We have, we no longer have a cubic polynomial. We now have a quadratic trinomial. So we'll go back and use big number method on this. So 6 times 15 is 90. And we want 2 factors of 90 that when we add them up we get 19. So there's 10 and 9. So we need to think about how to break up the 6x squared so that we could take it out of those. So, oops, not 6, sorry. We'll have 3x and 2x. Since I have a 3x here, I'm going to divide this by 3. And that equals a positive 3, which will go into this one. And since there's a 2x here, we'll divide this by 2, which equals a positive 5, which will go into this one. And those are my 3 dimensions. X, 3x plus 5, 2x plus 3. Pause the video and try got it 3. Okay, you should have ended up with these 3 factors. I will be looking at the work that you have shown for this to make sure that you did this on your own. So if you did not get these 3 factors, please rewatch how I did problem 3 and try again. Once you have gotten the correct got it's, go ahead and work through this lesson check. I will be looking at these problems in class. Please also write down any questions you have so you do not forget what they are, and we can go over that in class as well.